Hello, welcome back to video lecture 2. This is going to be a little bit on thermodynamics, but really we're going to be focusing on transport and the types of transport to get things in and out of the cell. So when we introduced this topic, we began talking about Gibbs free energy. Now this is not a super important idea for this unit, although you should expect maybe one test or quiz question on it. But it's going to be super important when we get into cellular energetics in Unit 3. So I'm giving you a little sprinkle now so that it becomes a little bit more easy and a little more digestible when we get to Unit 3. Now, in this course, you are never going to have to calculate your delta G. Instead, you would be given a delta G value, and you would have to make some decisions about that reaction based on that delta G value. So if we have a delta G value that is negative, then we would call it an exothermic reaction. And this means that it is spontaneous and that we would not need to put energy into what we call the system. So negative delta G means that it is spontaneous. We do not need to put energy into the system. Remember, spontaneous does not mean super fast. It just means that we do not need to put energy into the system to make the reaction proceed forward. Now, if it is a positive delta G, then the opposite is true. That means that we would have to put energy into the system. It is non-spontaneous, and therefore we would need energy in the system, and we would not get any energy out. Now, the second part that I asked you guys to remember was that if we add an enzyme, yes, it speeds up the reaction, but it will not change the delta G value. The delta G value is set basically by products minus reactants. So you will not ever be able to change the thermodynamics just because you add an enzyme. That's a really important thing that we're going to see throughout this course. And then if many of you I know are looking to go into higher levels of science, specifically in biology, and it's going to be really important in those courses as well. Okay, so it is important for this unit a little bit because when we start talking about active transport and diffusion, delta G is obviously playing a role in that. Okay. So the first thing that we talked about, the first transport type that we talked about was passive transport. Passive transport is where we do not need to use energy. Now, we might need a protein, we're going to talk about that in a second, but we do not put energy into the system, which means that these reactions would be considered spontaneous. They would have a negative delta G, and they will always move with the concentration gradient. That means that they are moving from high concentration to low concentration. Now, this should sound familiar because it should sound like diffusion. Well, diffusion, again, is just the movement of molecules from high to low concentrations. And for the cell membrane, that's going to be gases and nonpolar molecules. Now, let's think about why most gases are going to be in this scenario. Well, they're also nonpolar. So think about something like oxygen. Well, the chemical formula for oxygen is O2. It's an oxygen double bonded to another oxygen, two oxygens. And if we're thinking about how these electrons are distributed in these bonds, well, yes, both oxygens are very electronegative, but because they both pool on these electrons the same amount, they're actually going to be evenly shared. Which, remember, a polar bond is uneven sharing of electrons, so a nonpolar bond is going to be even, and it's because they're both pulling, they really want that electron, but they're fighting another oxygen for it. So ultimately, O2, or oxygen, is also going to be nonpolar, and it will pass freely through the cell membrane. Okay, so passive transport is divided into two categories. Simple diffusion, which is what we just saw, something moving from high to low concentration. Facilitated diffusion, it's still moving high to low concentration. That's the definition of diffusion, but it needs a little help. That's why we use this term facilitated. Facilitated means to help. The help that is being given is from a protein. So these protein channels and these protein carriers, they are going to be able to deliver molecules across a membrane, and they're typically going to be things that can't pass on their own. So things that are not nonpolar, aka they might be polar, it might be ions. Anything that is going with the concentration gradient, so still diffusion, but not going to pass freely through the rest of the phospholipid bilayer, they're going to need help from a protein. So we call that facilitated diffusion. Now, osmosis is a special type of facilitated diffusion, which we will talk about more in the next lecture. But remember that osmosis is going to be specifically referring to water across a semi-permeable membrane. And so this was a little bit confusing for some students, and I want you to pay attention now if it was. Remember that it's going to move for diffusion from high to low. Now, I think a lot of students see something like this and they say, well, that's high concentration. Except that's not high concentration of water. That's going to be high concentration of solute. So that could be something like sucrose. It could be something like sodium chloride. But because it's the same volume and more of that space is being taken up by something like a salt or sucrose, that means that there's actually less water on this right side of the beaker. So if we're moving water, that's going to be from high concentration of water on the left side to lower concentration of water in the right side. So be very careful with this. You're going to have to really think it through and verify that every step is correct. Otherwise, it'd be very easy to make a mistake on these types of questions. Okay. Now, the protein that is vitally important to this process is called an aquaporin. So an aquaporin is very important for osmosis across our cell membrane. Aqua, of course, meaning water, porin coming from the word pore. So just like a pore in your face is basically a hole, an aquaporin is a channel protein that is making a hole across your membrane and will deliver water from one side to the other side. Now, these are still working typically with facilitated diffusion, so we are not going against the concentration gradient here, and it is a channel protein, again, facilitated diffusion. Okay, that is in contrast, all of that, to active transport. So passive transport means no energy, and we have two types, facilitated diffusion and simple diffusion. Facilitated diffusion also includes osmosis, and none of that is going to require the input of energy in the form of ATP. But active transport does. So active transport is where molecules are moving against their concentration gradient. Let's go back all the way to delta G, which is going to be Gibbs free energy. If we are putting energy in, I am going to expect a positive delta G. I have to put energy in. It is an endergonic or endothermic reaction. So we have a special term for certain proteins that do this job. So again, they are moving against the concentration gradient from low to high. And we have a certain type of protein called a pump. So pumps are typically going to pump molecules against the concentration gradient. A very famous one here is the sodium-potassium pump, which maybe you've learned about in your other classes, maybe you learned about it last year. We're going to learn about it a little bit more later down the road, so we're not going to have to know exactly how it works today. But know that it is a pump. It's moving things against their concentration gradient. Therefore, it's going to require energy or require ATP. Okay, another type of transport that is not using a protein is going to be something called exocytosis. And we're going to talk about endocytosis in a second. But exocytosis is where an intracellular vesicle fuses with the plasma membrane. So intracellular, this prefix intra, is going to mean inside. So inside the cell, there is a vesicle that forms, just like we see over here, and it is going to merge with the cell membrane and spit out everything that it was carrying. So these vesicles become very important, but they're also transient. So when we talk about our organelles in a couple of reviews later, I want you to remember that vesicles are typically not permanent members. They form, they spit things out, they fuse with the membrane, they reform. They are basically delivery vehicles that go away and come back. Okay, so exocytosis is excreting something from the cell, spitting something out of that cell, whereas endocytosis is the opposite. If we played that video in reverse, it would have been almost this exact situation. So endocytosis is where a portion of the plasma membrane is going to fuse around a substance that enters the cell. So something is trying to enter. It's not using really a protein here. Instead, the plasma membrane wraps around it and then brings it inside into a vesicle, and eventually that vesicle will deliver it probably somewhere in the cell. We have two types of endocytosis. we have phagocytosis and pinocytosis. So phagocytosis is when we are taking in large substances. This could even be as large as something like a bacteria. So hopefully you remember from my last review video when I said that the prokaryotic cells typically are upwards of 100 times smaller than the eukaryotic cell. Well, we can take advantage of that, and if there is a bacteria floating around in our body, well, we have specific cells called phagocytes or macrophages who will come around and they will be searching constantly for those bacteria cells. And remember, think back, glycoproteins, those bacteria cells are not going to have the correct glycoprotein profile, and so they are not going to be able to evade these cells, these immune system cells, and instead they don't have the flag, so they're going to get eaten by these macrophages that are going to ingest them, and then hopefully they're going to fuse to something called a phagosome and then get killed. So that's the goal when we're dealing with the immune system, but we're going to talk about phagocytosis as well when we get to endocytosis in a lecture or two. Pinocytosis is very, very similar. The only difference is now we are dealing with smaller substances like liquids. So maybe you remember in class when I mentioned that phagocytosis, this prefix phago or phago, depending on who you talk to, it is going to mean eating. Cytosis means of or pertaining to the cell. So this is eating of the cell. Pino here means drinking, so it is drinking of the cell. That's how I remember it. I also gave you the example of hyperphagia. Hyperphagia is when certain animals can't stop eating. This is very common in Labrador retrievers. So if you see really, really chunky labs, it's typically because they might have some sort of gene that increases their, basically their appetite, so they don't stop eating ever. And it becomes a big problem. Okay. So that is our transport lecture. I hope now you feel a little bit more comfortable with those topics. Remember that we are always thinking big picture, thinking application, and I will see you in our next review. Good luck!